Assalamu alaikum. I'm Iftikhar Rahman. In this video, we'll be presenting our final lab project, which is a line following robot. So let's get started. To build this project, we need to create a world where we have the background lights, and the track. To create this background, we have to go to this add button. And after clicking this add button, we can get some options, and we'll be clicking the Protonors Weaver projects, this option. And under this option, we can get some subsection like default device humans. We don't need this. We just need the object. So we'll click the object section. And under the object section, there are so many options. We'll be clicking the background option. So here is the texture background light, and we'll be clicking and import it. As we have already imported it in our project, so we are not clicking it, we are just cancelling it. And in the same way, we'll be importing the background light. After importing the texture background and texture background light, we'll be importing the floor. So again, we'll be clicking the plus option, we'll be clicking the Protonors Weavers projects option, and we'll be clicking the objects. And under the object section, there is an option like floors. And under the floor subsection, there are so many sections like circle arena, floor, rectangle arena, and uneven terrain. So we'll be clicking the rectangle arena as we are planning to create a rectangular section, a rectangular floor basically. So again, we are not clicking it because it's already in our project, so I'm just cancelling it. And after this rectangle arena option, there are so many options and there are so many properties basically. And we'll be just updating, or we'll just give some values as like wall height. We can give some wall height. We can give also wall thickness, and we can give some floor size. And by increasing and decreasing values, we can see the changes of it. And after that, we'll be creating our line where our robots will be perform our robot.
Hi, I'm Preetham Paul, and I'm going to tell you how I added the sensors to my robot. After the world has been built and the robot has been created, it was time for me to add these sensors, for which we need to go to the robot, go to children, and then press on add. And after pressing on add, we click on base notes and we go down, find distance sensor, and then we add it. And we are going to add a total of three distance sensors and name them. The middle one is DS middle, the right one is DS right, and the left one is DS left. After three of them has been made, we change the translation according to the places and the location they're settled in. Then we change the rotation of three of this distance sensors so that it covers an area and an arc. And after that, we need to change the uh, type to infrared for all three of them. We have to change the infrared for all three of them. As you know, I have already done it. Then we save it, and then we would see that the distance rays would not be initially present, but we need to make sure that we use view, we use go to optional rendering, and we have the distance sensor rays as ticked. Then we need to make sure the names of these distance sensors actually matches with the names on the code. Right, for here it's written DS right, DS middle, and DS left. We have to make sure that the names here and the names here matches, otherwise the code won't work. Thank you.
Hello, I'm Arshal Hussain. So at first we have created a world and we have created a robot with sensors. So the next task is to create a path which the robot can follow. So to create a path, first we have to go to the Tinkercad and create a new design here. And now we have to draw the path. So here we can draw a path which the robot will follow, and then we can proceed further. So we can reduce the height to 0, and also we can change the color of the solid. So I'm doing it black, and after that we can export the 3D model of the path, and then on the keyboards we will go to the file section and import the 3D model here. So now to position the path inside the border, I have changed the translation and the rotation part, and also I have changed the scaling of the robot to place it on the path. My next member will implement the PID algorithm and show how the code works. So we use the PID control because it's the most widely used strategy, as it is the simplest controller function, and also it eliminates steady state error and provides a fastest response. So up to this was my part. I hope I can make you understand.
My
Thank
name
you.
is Pushpakali Kesha, and I will be explaining the LFR Python implementation part of our project using PID. At first, the controller is set to the Python name, which is PID final. Then our left motors are our left and right motors of both the front and back part are renamed accordingly, which is will 1, will 2, will 3, and will 4. Here the last error I, D, and P values are set to 0, and the values of KP, KI, and KT are set accordingly. Now initially the velocity of the motors are set to 0, since initially the the robot should be at stationary. And after that, using the value of get value, we can get the values of the sensors, and then we are printing the values of all three sensors respectively: left sensors, middle sensor, and the right sensors. And here we have set the sensor threshold to 950, which means if it is less than that, the robot is on track, but if it is more than that, the robot is off track. Whenever the mid sensor is on the line, we will get an error value of 0. But if the middle if the left sensor is on track and the other two sensors are off track, we will get a positive value, which means the robot will turn left, and when we will get the negative values when the right sensor is on track and the other two sensors are off track, and which means the robot will turn to the right. And when all three sensors are on the line, it gives us an error value of 1. Using these three lines, we can calculate the balance, and the balance is used to adjust the left speed and right speed of the motor. So when the error value and the balance value is 0, we can say that the robot moves in a straight line, and their left and right motor velocities are set accordingly to their left and right speed. But when the error balance is positive, the left the left motor velocities are 0, and the right motors are right speed, which means the robot moves left. But if the error and balance value is negative, the robot moves right. As a result, their right velocities are set to 0, and the left motor velocities are set to left speed. And whenever the motor turns aggressively to left or right, which means the left speed is less than 0 and the right speed is also less than 0, their left and right motor speeds are multiplied by 1.5 times, since it moves more aggressively than usual. So this was our code for the PID part. Unfortunately, we could not implement the code properly. As a result, the robot moves in a doesn't actually quite moves along the track. Thank you.